In this video, we're going to look at the power and quotient rules with positive exponents. And so basically, we're just going to be simplifying a bunch of things that have powers raised to powers, and there's also some division going on in them. So for example, simplify. So the first one we're going to look at here is a to the fourth, b to the third, over a to the third b. And all of that raised to the fifth power. Now, there's lots of ways to do these problems, and there's not really a right way. There's not just one way to do the problem. But I do follow the one way that I do the problem every single time. And so what I do is I first take this exponent here and I distribute it to each of the pieces. Now remember a couple things. One of the things to remember is that this b down here, it doesn't have an exponent, but it's really a 1. So when you have a variable and there's not an exponent written, it's really being raised to the first power. So the other thing is that to remember that when we distribute this exponent, we multiply. So this is going to become a to the 4 times 5, b to the 3 times 5, divided by a to the 3 times 5, b to the 1 times 5. So if I work that out, it would be a to the 20th, b to the 15th, divided by a to the 15th, b to the 5th. Okay, so now I've gotten rid of these parentheses and this exponent out here. So now all I have to do is simplify this piece here. So what I do is I look at the top and the bottom and I see if there's any variables that are alike. So there's a's on top and a's on the bottom. And then I ask myself, where do I have more a's? So if you look, do I have more a's on the top or more a's on the bottom? In this case, I have more a's on the top. And then I ask myself, how many more a's? So if you notice, down here I have 15, but up here I have 20. So I have 5 more a's on the top. So I'm going to be left with an a to the 5th. Sometimes you'll see people do this. They'll cancel them. So they'll say that the 15 a's, they'll say that these 15 a's cancel out 15 of these, and we're left with 5 of them. Now we go on to the b's. So if I look, on the top I have 15 b's, on the bottom I have 5 b's. So where do I have more b's? Hopefully you're saying the top. And how many more b's do I have on the top? So I have 10 more b's on the top. So this is going to be b to the 10th. And again, you could cancel it by saying these 5 b's cancel out 5 of these, and I'm left with 10. So my final answer here is a to the 5th, b to the 10th. So we'll do some more examples. I think you can never have too many of these types of examples. So I have 4 of them. So my second example here, we have m to the 6th, n to the 3rd, divided by n squared, this should have been m squared, n to the 5th, all to the 3rd power. So again, the first thing I'm going to do is I'm going to distribute this 3. So if I do that, we end up with m to the 6 times 3, n to the 3 times 3, divided by m to the 2 times 3, n to the 5 times 3. And if I simplify that a little bit, I have m to the 18th, n to the 9th, divided by m to the 6th, n to the 15th. And now I just have to figure out what I have where. So if I look, I have 18 m's on the top and 6 m's on the bottom. So I have more m's on the top. And how many more m's do I have? I have 12 more m's. So left on the top is going to be m to the 12th. So again, you could think of it as canceling these 6 m's out, cancel out 6 of these, so I'm left with 12. If I look at these, I have 9 n's on the top and 15 n's on the bottom. So where do I have more n's? The bottom. And how many more n's do I have? Well, I have 6 more. So I would be left with n to the 6th on the bottom. Or I can think of it as canceling out these 9 n's, cancels this out, and I only have 6 of them left. So we'll look at another one here. So if I had 2x squared y to the 7th divided by 10y to the 4th, all raised to the 2nd power. So again, the first thing I'm going to do is distribute this 2. The thing to remember, so this is going to become, so before I distribute it, I also want to remember it's going to have to get distributed to the numbers as well. And so remember there's a 2 to the 1st power here. Again, even though I don't write that power, and there's also a 10 to the 1st power. So remember that this 2 is being distributed to the exponents. So it's not going to be 2 times 2. It's not going to be 10 times 2. It's going to be 2 times this exponent, 2 times this exponent, 2 times this exponent, 2 times this exponent, 2 times this exponent. So it's going to be 2 to the 1 times 2, x to the 2 times 2, y to the 7 times 2, divided by 10 to the 1 times 2, y to the 4 times 2. So 2 squared, x to the 4th, y to the 14th, divided by 10 squared, y to the 8th. And again, if I work out what 2 squared is 4. So I have 4x to the 4th, y to the 14th, divided by 100 y to the 8th. And so now I'm going to simplify things. So the first thing I'm going to do is I'm going to look at the number parts. So 4 and 100, so 4 actually goes into 100 25 times. So 4 goes into 4 one time, 4 goes into 125 times. I only have x's on the top, so there's nothing else for me to do with them. And then on the y's, I have 14 y's on the top and 8 y's on the bottom. So I can cancel some of those out. So these 8 y's will cancel out in the 14 and leave me with 6 y's left. So my final answer here is going to be I have an x to the 4th, y to the 6th on the top, and I have just the 25 on the bottom. So I have one more example for us here. This one looks a little bit different, but it's still the same general idea. So I have 2n to the 6th, all raised to the 2nd power, divided by 4n cubed, all to the 3rd power. So again, the first thing I'm going to do is I'm going to take this exponent and I'm going to distribute it to the stuff in the parentheses. So again, remember that this 2 has a first power, this 4 has a first power. So this 2 has to just be distributed and multiplied times both the 1 and the 6. This 3 has to be distributed times the 1 and the 3. So this is going to become 2 to the 1 times 2, n to the 6 times 2, divided by 4 to the 1 times 3, n to the 3 times 3. And so if I work this out, we end up with 2 squared, n to the 12th, divided by 4 cubed, n to the 9th. And if I work out what those are, 2 squared is 4, and 4 to the 3rd power is 64. So I have on the top, I have 2n to the 12th, and then I have 64n to the 9th. So again, the number parts, so 64 is divisible by 4. And you can do that on your calculator. So 4 goes into 4 one time, 4 goes into 64 16 times. Then the n part, I have 12 ends on the top and 9 ends on the bottom. So the 9 ends on the bottom cancel out with these 12 and leave me just with 3 left over on the top. So I'm left with n cubed divided by 16. And that is the final answer. So again, there are multiple ways to do this. Alex may show a different way to do these. You can simplify the insides first and then distribute, but I personally just like to distribute from the beginning.